Okay, welcome to week 6. So this will be the last lecture of the course since we're doing our group presentations next week at this time. I wanted to start out by going through the string handling methods that we didn't quite get to last week. And I also wanted to give you a brief introduction to the idea of classes for doing object-oriented programming in Python. Now, I won't be giving you a homework for any of this, so this is, in the nature of informational stuff that you ought to have seen. We will have a quiz starting at 10 after 8, and I have my obnoxious kitchen timer here to remind me to shut up in time for that. And it is obnoxious and it is reliable, so... All right, well, let's get into things. Anybody have any questions from last week before I start? All right, so we've looked at a few ways of interacting with strings. We know that we can use a plus symbol to concatenate two strings together. We know that we can use a times symbol, a star symbol, to get a repetition of strings. We know that a string is a kind of sequence, so we can index and get a one-character substring from a string using an integer subscript within the string. And we can also use slicing with the colon. A particular function that you folks have made use of quite a bit is the split function that takes a string and splits that string at a certain character into a list of strings. Now, in addition to that, there are oodles of other methods that you can use to manipulate and interact with and find out about strings. And the gory details are in this online documentation. Here are several examples. I'm going to start out with a string just containing, this is a test in lowercase. Well, if I could type. Come on. And there we are. So now if I say s dot capitalize, that just capitalizes the first character, which seems like a heck of a lot of work to do to capitalize the first character. But there you are. There's another sort of, I think, odd method called title that gives you the first character of each word capitalized. Upper converts every single lowercase letter to uppercase, and the analog of that going the other direction is lower. If I say this is a test with mixed case lower, then it all gets converted to lowercase. Okay. Holler at me if you have any questions. Most of this stuff is pretty simple. I just want to zip through it so that you have seen it. All right, let's suppose we say S gets some word. Now, I can center S, I can center that string in a field of some certain width. Here I'm saying center that word in a field 10 characters wide. And what I get, since this is an even numbered number of characters in Word, is 3 spaces ahead of word and 3 spaces after word. So I have a total of 10 characters in this centered word. If I wish, I can center the word with some fill character, or actually some fill string. So if I say give me S centered in a 10 character wide field using dot as fill, then I get dot 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 word dot dot dot. I can also left and right justify things by using ljust. So s.ljust 10 gives me a 10 character wide string with s left justified within those 10 characters. So here I've got word followed by 6 spaces, and it won't shock you to know that you can also right justify a word, or a string I should say. And both of these also you can specify a fill. Okay, so there's left justified with exclamation marks as my fill character. Strip we have already seen, so let me say s gets s.center 10. So now s is this modified version of the original s, which does contain some spaces in it. And if I say s.strip, it turns out that the strip function takes all the white space from the beginning and the end on both sides. So I just have word left. If I only want to strip the right side, I can say rstrip. And on the other hand, if I only want to strip the left side, I can say lstrip. Now, strips white space of all kinds, so not just spaces, but also tabs and new lines, and much less common things like form feeds and vertical tabs and whatnot. So if I say s gets a new line plus the current version of s plus, let's say, a tab and a space and another tab and another new line. All right, so now s has spaces, tabs, and new lines in it. S.strip gets rid of all of that stuff. S.lstrip gets rid of everything on the left. S.rstrip gets rid of all the white space on the right, and so on. So, in particular, I just wanted to point this out because strip is sometimes too powerful. It's sometimes stripping too much stuff. If you are, you remember our regular expression examples where we're looking at that poem where a bunch of the lines were indented by 2 spaces. If you were trying to process data that looked like that, where some of the lines were indented, or some of the lines ended with tabs or something, and you wanted to get rid of the new line at the end, you would not want to use strip because it's going to get rid of all the white space on both ends. So that's why we chose, when we had a line that looked like improve his shining tail. Let's suppose that we read that in from a file. Coming in from the file, it ends with a new line, but it also happens to begin with a couple of spaces. This is why I wanted to say processed line, to pick a different variable name, ln sub colon 1 minus 1, because I want, wait a minute, why didn't that work? Up to but not including minus 1. Oh! Okay. I didn't change ln. I changed processed ln. And I got rid of the new line at the end, but I did not get rid of the spaces at the beginning. So that's why, that's why my preference, if I'm processing lines from a text file, is to just trim off the last character rather than white space generally. Now, I may later on want to get rid of white space, and then I can use my strip or lstrip or rstrip. I do also want to point out that stripping only affects the beginning and end. So if I say s gets, this is test Someday I will learn to get that final quote mark in there. There we go. All right, so if I say s.strip now, the interior extra spaces and tabs don't get touched by stripping. Make sense? Wrong question. Do you understand? Okay. There are also Boolean tests that I can do. So here I have s getting this made-up word, fantabulous. And if I ask s.isLower, that's a Boolean test or a predicate asking about the contents of s, and that is true. If I say s.isUpper, that's false. If I say s.isAlpha, that's testing whether s is alphabetic, and that's true. s.isNumeric is false. A lot of these predicates, for those of you that have ever looked at C programming code, these are more or less directly stolen from the C programming language with some sort of annoying and arbitrary differences. In C, I would say s.isNum, but for whatever reason in Python they decided to change the spelling. I don't know. I think Python programmers are smart enough to know what isNum is. If I say s gets okay, rather than saying s gets something, let me just say catch 22. There's a string, and I can execute or invoke a method directly on the string. I don't need to have a variable referring to that string. So let me ask whether this is alpha. And of course it's not. It's also not numeric. But it is alphanumeric, which I get by saying alnum. Okay, so again, I mean, alnum is directly from the C library, so it seems puzzling that we don't have isNum, but whatever. I'm stupidly editorializing and wasting your time. So far, so good. There's even a method that you can use to test whether a string is a valid Python identifier. So root 66 is identifier. Okay, because the rules for Python identifiers is that we have to have an uppercase letter, lowercase letter, or underscore as the first character, and then upper lowercase letters, underscores, and digits as remaining characters, and so that satisfies that. But 23 skidoo is not a valid identifier, so we get false from that. So how many of you have ever heard this term 23 skidoo in your life? Nobody. So I think I must have read very old books in my grandfather's library when I was a kid. Because it turns out that 23 skidoo in the very early 1900s was as common as groovy was in the United States in the 1960s. And it's basically just a slang term meaning, let's blow this joint, let's get out of here. Why? Who knows? But if you look up 23 skidoo on Wikipedia, you can find out all about it. All right. Let's see. Is title... Oh, is space. That's an important one. So if I have any combination of spaces, tabs, new lines. Let me throw in a carriage return, which we don't usually see, or a vertical tab, which we essentially never see. And I can ask whether these things are space characters, and I'm told true, all of the characters in that string are space characters. Okay, well, we've looked at split already. Now we're going to take a look at join, which is the opposite of split. Join is a cool function, but it's a little mysterious to get used to. If I say S gets, this is a test, and so there's one string S. If I now say M1 gets S.split at spaces, we know that we're now going to get a list of 4 strings from S. Okay? Now, if we want to join those things back together that we've split, you might think we should say M1.join, but no, join is not a method of lists. Join is a method of strings, and so it sort of looks backwards how we have to do this join. We say space as our string first, and then say that we want to join all of the items in this iterable M1 together with spaces, separated with spaces. So space is our separator character here, and around spaces we're joining the 4 strings that are in M1. There's no limit on what kind of string I can use to do my joining. So if I say plus 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 join M1, I get those 4 strings joined together with plus plus pluses in between. And the iterable can be anything, so I could say I don't know, colon dot join range 10. Oh, duh, those aren't strings. Well, that's not a problem, because I can say dot join list stir I for I in range 10. Okay, so just use a comprehension to get those things turned into strings. And there I have, 0 through 9 separated by colons. Everybody good with join? You can find out how many times a certain character or a certain string appears within a string by saying s.count. Let me count the t's, for example. And there's 3 t's. Let me count the is's. And there's 2 is's. Of course, there's the word is, but there's also the is in this as well. We've already talked about how to use regular expressions to match certain patterns in strings. Somebody asked me, I think, about doing substitutions, which is an example I didn't show. So let's take a look at that. Here's my S, and if I say mt1 gets, I better import RE first. Now if I say mt1 gets re.search t in S, MT1 is a match object that tells me, hey, there's a T at location 0 up to but not including location 1. I can now do an re.sub. And notice that sub takes a pattern followed by a replacement string followed by the input string. So let's suppose that I wanted to change little t to capital T in this string s. So I can say re.sub little t to capital T in s, and I get, in fact, all of the little t's changed to capital T's. If I did only want to change the first one, I would say re.sub little t capital T s, and then count equals 1. And that only changes the first one. All right, so sub is a natural follow-on to search that allows you to replace one regular expression with another. Now, if I wanted to know where these characters were, I can do a find in my string. All right, so s contains, this is a test, and if I say s.find t, by default, find will start looking from the first character, and it will report back to me the position of the very first t that is discovered. This is a subscript, so what I'm going to get back here is a 0. Now, if that is not the one that I was interested in finding, I can also give find a position to start from. So if I say s.find little t starting from position 1, then find will start at sub 1 and go forward until the next little t is encountered. And I get told that the next little t is at position sub 10. Okay, so there's my sub 0 little t, and here's my sub 10 little t. So if I then find little t starting from position 11, here's my final little t, and from there, if I continue trying to locate little t's even further on, when I get back a -1, that means that there aren't any found, okay? This is very definitely not the same thing as like a negative subscript when you're doing a subscript into a string or into a list or something. All valid return values from the find method are going to be non-negative values. If you get back a -1, that doesn't mean that the t was found at the end. It means that there wasn't any t found. And of course that makes sense because in this case the length of s is only 14, and so position sub 14 is not even in the string anymore. It's actually one past the end of the string. I can search in the reverse direction by using rfind rather than find. And I can search for arbitrary strings. I don't have to just search for individual characters. Unfortunately, find is not smart enough to use regular expressions. So if I want to use regular expressions, I have to use the re.search instead of the find. Okay, any questions about what's up with find? Okay, so just for gags, here's my S. If I wanted a list of all the indices of the little t's in here, Well, I was going to use find, but I see I'm not using find. Okay, well, so that isn't quite showing what I wanted, but it still gives me the right results. Okay, so I was trying to show a comprehension using the find command to be able to identify where all of these strings were, but I thought of an easier way first, so it didn't quite work out. Anyway, everybody okay with find? All right. All right, so here's the replace of just plain strings, not the regular expression substitution. So if I have s containing this as a test, and I say s dot replace little t with t, by default, all of them get changed. But again, as we saw with the regular expression substitution, I can specify that I only want one changed. Takes no keyword arguments. Then why did you tell me you took a keyword argument? Interesting. Well, you know, documentation sucks. What can I say? So you can't say count equals, you just say the count that you want, and that tells you how many replaces to do. Okay, now one of the, to me, really frustrating things about Python is that, like, every couple of releases, somebody designs a much better way of doing formatted output than anybody else ever thought of before. But the problem is that they never remove the old things. So you've got, you know, so if you want to know how to format output in Python, you've got like 4 completely different sets of notation that you should memorize if this is your thing, I guess. But for almost all formatting that you are likely to encounter in real life, the formatting that we've talked about using the curly brace colon with the format specifiers like D for decimal integers, F for floating point, S for string, that will solve 99% of your cases. And invariably, when somebody comes out with one of these brand new mechanisms for formatting output, their justification is some super obscure case that perhaps they found once and needed to have a general perfect solution for, which to me is just immensely annoying. So just as a, I already sort of beat you up with format, right? We did talk about using format to format things. Yes? No? See, I'm teaching 3 different Python courses right now, and I can't remember what I said to whom. Well, anyway, as a reminder or perhaps an introduction, the format specification, if you use the .format method, at its simplest consists of a pair of curly braces where the first curly brace, the opening curly brace, is followed by a colon, and then you have a letter indicating how you want to format that particular value. If the value you're trying to format is an int and you want to see that integer in base 10, then the format code you use is a little d for decimal that is base 10 integer. And people always want to know, well, that's kind of stupid, why isn't I? And that's reasonable. But the reason that it's not I is because in addition to D for decimal, we can also use X for hexadecimal, O for octal, base 8, and B for binary. So we have many different ways of formatting integers. It's just that decimal is the most common way. S is for string. And then the 2 most common floating point format codes are fixed point, which means that you do see a decimal point but no exponent, or exponential, which is basically scientific notation, meaning that you always see an exponent. Okay, so let me just do a really quick, simple example of this. If I say print colon D colon X colon O colon B colon S colon F colon E. Okay, so that is my format string. It says that I want to format 7 values. The first 4 of the values are going to be integers that I want to have displayed as decimal, that is base 10, hexadecimal, base 16, octal, base 8, binary. Then I want to display a string, and then I want to display a floating point number in fixed point and in exponential notation. So let me say format and give my values. So let's say 127, 127, 127, 127. That's my integer value that I want to see 4 times. Then I'm going to say high, and then I've run out of space, so on the next line down I'm going to say 13/7, 13/7. Those are my floating point values. And I want print to print these things out neatly on my screen. There we go. So 127 in base 10 is 127. It's no big surprise. In hexadecimal, 127 is 7 times 16 plus 15. Okay, so 7F is the base 16 representation of the same value as 127. 127 is 8 1-bits in binary. I'm sorry, 7 1-bits in binary, which in base 8 is 177. That is, it's 64 plus 7 times 8 plus 7. 64, 56 is 120, and 7 is 7. So 127. High is high, big deal. And then here we have our 13/7 as a floating point, I'm sorry, as a fixed point number with a decimal point and no exponent. And here we have the same thing in scientific notation where the exponent is required to be displayed even though it's 0. Good? So in addition to these trivial format specifications, you can then also specify a width between the colon and the format code, and that will determine how many characters wide your output is. So if I were to run this same thing again, but indicate that I want these to all be in fields that are, let's see, 12 characters wide. Well, no, let me have 9 for my decimal, 9 for my hex, 9 for my octal, 9 for my binary. I'll just leave the string, well, I'll do 5 for the string, and 11 for the float and the exponential. And so that we can see the boundaries of these things, I'm going to put vertical bars in between everything. Okay, so the bottom line is that the curly brace colon followed by a number, followed by an integer, specifies how many characters of output to display at minimum. It will actually print more output if necessary if the output value is too big to fit. Let me demonstrate that. Let me say colon 1D for the first number that's being displayed. Well, 127 can't be printed in one space, so it will take 3 spaces because that's the minimum necessary to display 123. There we go. So I asked for 1 character of output for the decimal number, the base 10 number, but I got 3 because I've got to have at least 3. Here I have 7 spaces and 2 characters for the hexadecimal, 6 spaces and 3 characters for octal, 2 spaces and 7 characters for binary, 5 for string. Notice that the string is left justified in the field by default, whereas all the numbers are right justified. And then here we have an 11 character wide field for the fixed point, and also 11 for the exponential. Good so far? All right, and here's another similar kind of example. Now, you can also specify between the colon and the width the left angle bracket, the caret, or the right angle bracket to indicate whether you want to have the output left justified, centered, or right justified. And for floating point numbers, you're allowed to specify the precision, that is the number of characters after the decimal point that you want to see. So let me make a big copy and paste of this whole thing again. And I'm going to ask for 11.3 for the 2 floating point formats. And I'm going to ask for left justified, centered, and right justified output. I'll ask for the string to be centered. Okay, I think that's enough to make the point. Okay, so here I have a left justified hexadecimal number because of the left angle bracket. I have a centered octal number. I have a right justified binary number, which I would have gotten anyway because that's the default. Here I have a centered string and a right justified fixed point number with 3 characters after the decimal point, as well as a right justified 11 character wide field, 3 after the decimal point for the exponential. Isn't that exciting? Now, so I've spent a lot of years not only writing code as part of a programming team in various capacities, but also working for individual clients, small business and large business clients as a consultant. And if you don't know this already, I will tell you that your customers want to see clean output from your programs. And they will be really happy not to know that you have memorized this stuff, but they will be really happy that you can just produce beautifully formatted columns of numbers and strings on demand under any circumstance. It will just thrill them. Or to put it a different way, they'll be upset if you can't do it. All right, so this is it's a nuisance, but it's something worth just committing to memory and practicing with until you can do this without having to look things up in your manual. And then once you've learned this really flexible, really tiny little part of the Python formatting stuff, you can waste enormous amounts of time learning all the other tools that accomplish the same thing. All right. Any questions about string handling? Okay, not very exciting, I will admit, but very important also. Let's take a break here, and then we're going to dash through looking at classes, how to define classes, and how to use inheritance in Python. I want to take a break now because I don't want to take a break, like 10 minutes before the quiz. So, let me fire up my... Okay, welcome back. So we have mostly in this class been using Python in a procedural programming kind of way. Programs have mostly consisted of get some data, analyze some data, produce some output, and it's just been step by step by step by step. And along the way we have used objects, lists and dicts and ND arrays and data frames and so on. These are all examples of objects that belong to certain classes. But we haven't yet talked about how to create classes of our own. So in order to create a class, or I should say what a class contains in a Python code, is a collection of data attributes that keep track of the current state or value of the object, and methods or functions or symbols that you can use to interact with the object. It's also possible in Python to have nested classes, so that if you have a complicated class, part of it might involve storing information in a smaller kind of inner class that's invisible to the outside world. But we don't need to get into that level of detail. Okay, so when you define a class, the first method that you have to have for the class is something called the initialization method that knows how to set up the initial state for the object. And all methods that you define, including the initialization method itself, come here, you. Receive as their first argument a reference to the current object. You can call that reference anything you want. You can call it X or banana or cow or whatever, but the conventional name that everybody uses is self. And the main thing that I'll have to say at this point about self is that when you're first writing class methods, you're going to forget to put it in, and you're going to get mysterious error messages that won't help you figure out what you did wrong. Okay, so that's lesson 2, I guess. When you define a class, you have to have an initialization method, and that method and every other method that you create has to have self as its very first parameter. All right, so we're going to take a look at a simple class with an init method. Another thing that you essentially always want to do with any class is to be able to see a representation of that of objects of that class, and for that you're going to want to have a stir conversion method that knows how to represent the internal state of the object as a human readable string. So let's imagine that we are writing a human resources application, and in our application we're going to have companies and departments and on and on, projects and so on. We're also going to have employees. How do we define an employee? What state, what information does each employee have to contain? Well, in our company, an employee is going to have a name. An employee is also going to have an ID number, which is usually assigned when the employee is hired. And that number never changes, although the name, could change if the person gets married or becomes famous and decides to drop their last name. If you've hired Cher, for example. And employees probably want to get paid, so each employee is going to have a current hourly rate. We're just going to deal with everybody on an hourly basis rather than have hourly versus salaried people at this point. All right, so that really trivial is what each employee is going to have to know about itself. In Python code, whoops, I jumped the gun a little bit. In addition to each employee knowing this information about itself, we are going to need in our program to be able to create employee objects. We're going to have to be able to see a representation of an employee object as a string. And not only do employees like to get paid, but they also like to get raises. So we're going to have some way of giving an employee a raise. Now the bad news here is that the raise can be a negative number. But we'll have a way of giving an employee a raise. So here is our code to implement this concept in Python. We say class employee. And this introduces a new data type for Python to know about. In this employee class, and notice that these are all indented one level, we have 3 methods. The first method is our initialization method. The second method is our string conversion method. And the third method is our giveRaise method. All right, so those are the minimum things that we've decided we need to be able to do to interact with employee objects. We need to be able to create one, we need to be able to look at one, and we need to be able to give one a raise. All right, you'll notice that for each of these 3 methods, self is the first parameter. And in fact, for the string conversion operation, self is the only parameter that we have. And I'll repeat that one of your first common problems when you're starting to write classes yourself is that you're just going to forget to say self as the first parameter, and that will drive you bananas. All right, now in addition to self, for our initialization, we're going to need to pass in, when we hire an employee, that is when we create an employee object, we're going to need to pass in the employee's name, the employee's ID number, and the employee's hourly rate for this person that we're hiring. All right, now these things are parameters. Name, ID, and rate are parameters. They just get created when this method gets called, and they disappear as soon as the method returns. Okay, so they just go away. But we need to be able to hang on to those pieces of information internally within the employee object that we're hiring, or the employee object that we're creating. So in this current object, self, I'm going to save in an attribute called underscore name the name that was passed into the method. I'm going to save in underscore ID the ID that was passed into the method, and finally underscore rate is going to contain the hourly rate that was passed into the method. Why have I named these things starting with underscores? Well, I'll say more about this in a minute, but for the moment, underscore is intended to inform somebody reading this class code that these are to be treated as private attributes within the employee object, and they should not be directly monkeyed with by outside code. Okay, so here is, at the bottom of this module of code, I have some testing code that is going to create and interact with a couple of employee objects. My first employee object has the name John, the ID number 1, and the hourly rate 60.50. Okay, so when I create an employee object, that calls the init function, get rid of all this yellow, that calls the init function, and those values, John 1 and what was it, 60.5? Yeah. So John 1 and 60.5 are the values of the name, ID, and rate parameters passed into this initialization function. And so those values get saved in these three attribute values for the John object. Underscore name is John, underscore ID is 1, underscore rate is 60.5. A little bit later, I'm creating another employee named Ed. Okay, so Ed's name is Ed, Ed's ID is 2, and Ed's rate is 72.25. All right, so that again calls the initialization function. Ed is a different self. Okay, so John has a self, and Ed has a different self. But each of those objects, the John object and the Ed object, keep track of the information, underscore name, underscore ID, and underscore rate, independently of each other. They each have their own name, they each have their own ID, they each have their own rate. So far, so good? I might as well mention here, I haven't before, that these special methods like init and stir, these names, whoops, oh, whoa, I hit the home button, yikes. These special methods have names that start with double underscores and also end with double underscores. When you look in documentation, you often don't see any gap between the two underscores, so it just looks for some reason like in that font the underscore is really wide. But it is in fact two underscores, okay? And nobody likes to say aloud that the name of the initialization method is underscore underscore init underscore underscore. It's too painful to have to say underscore 4 times. So the convention in Python world, maybe I've already said this when we talked about main and name, I've forgotten. These things are called dunder names. So dunder init means double underscore init double underscore. So we've got dunder init and dunder stir. For essentially any method, any class that you create, you'll need those two methods. All right, so we've created this employee named John, and we can convert the employee John into a human readable string by calling the stir function. The stir function turns around and invokes the dunder stir method. And so for John, this is going to return to me a string, ID colon space, followed by the ID number converted to a string. So ID 1 concatenated with comma name colon John, concatenated with comma salary colon, and then I want to format the hourly rate to just have two digits after the decimal point. So the salary is going to come out as 60.50. Okay, so when I run this code, John gets converted to a string explicitly and then printed, and that's where this first line of output comes from. But you probably remember that I said when you call the print function itself automatically converts all of its arguments to strings. So the print function internally is going to invoke stir on John anyway, and so for the second output of print, I get exactly the same result. So technically speaking, in this first in this first print function call, I'm saying print stir John. What's actually going on is that John is being converted to a stir, and then that stir is being converted to a stir again. But converting a stir to a stir doesn't actually do anything. So the output looks the same as if I did a print without the explicit stir function call. Okay, so then for ed, the same thing happens. I'm creating ed and I'm displaying ed, which is going to invoke the dunder stir method. And ed, I'm going to give a raise to, and I'm going to give a raise of 10%. So let's see what the raise function does. Okay, so in the raise function, I always have the self argument. That's always implicit. And it's, as I say, very easy to forget. The percentage here is going to be converted into a ratio by just dividing percent by 100. And then we're going to multiply the existing rate by 1 plus whatever that fraction is. So if my percent is 10%, my self._rate is going to be multiplied by 1.1. And so ed is going to get a 10% raise. So in other words, ed's _rate attribute has its value increased by 0.1. Okay, so initially when we look at ed, when we print ed has the rate that ed was hired with, 72.25, and then later on ed's rate has been increased by 10%. Anybody have any questions so far? It's easy to look at all of this gymnastics, all of this weird syntax, and think, well, gee, that seems awfully hard. What's the point? Well, the point of doing this hard work of creating the class is so that whoever is using your class has an easy job. Here, this code on slide 28, the way I've written it here, is intended to be at the bottom of the same part of the file where the class was defined, up above. But you can imagine that the class was defined in one module, and this code is defined in a completely separate program that has imported the employee module, and now the person who's using the employee objects has a really easy time. We can say create an employee named John with ID 1 and a rate of 60.5, display John, give John a raise, create an employee named Ed with an ID of 2 and a rate of 72.25, display Ed, give Ed a raise. Creating and interacting with employees is really easy for the application programmer, assuming that the class developer has done a good job of defining the interface to the employee objects and defining the correct state within each of the employee objects. Okay, so the idea of creating a class is to make life easier for application developers. Questions? Okay. Now, so far, our employees really can't do very much. And so we're going to take steps to fix that. But I guess in the meanwhile, I want to come back to this thing I mentioned a bit ago, which is that in front of attributes within each object, and also in front of so-called private helper functions, you want to put an underscore in front of the name to give the person reading your code a hint that they should not go in and directly access that attribute or that private function. Now, unfortunately, there's no enforcement of this privacy in Python. in Python, all application developer behavior is voluntary. And so we wish that the application programmer would respect the desires of the class designer and not use these attributes and functions whose names start with underscore. But application programmers can totally ignore you. And so here is some application code that is ignoring the privacy and directly testing whether John's underscore rate attribute is greater than Ed's underscore rate attribute. If so, we're going to display that John, whatever John's name attribute is, makes more than Ed, whatever Ed's name attribute is. So this could be completely outside the employee class, and just the application developer here is totally ignoring my preference for keeping this information private within the class, and just directly accessing the data. Well, what's wrong with that? Well, what's wrong with that is that the application programmer can also say things like John.name gets quote well, John isn't defined, but let's assume that we did have an employee object named John. The application developer who has just hired this person named John can directly jam a totally nonsense string into John's name, and the employee class has no way of detecting that this happened, has no way of preventing a bogus name or a negative rate or a Boolean employee ID from being assigned into the employee object. Most object-oriented languages like Java, C++, C#, Objective-C, etc., do have protection for attributes. So that if you attempted to do this kind of thing in Java or C++, you would get an error message from the compiler saying, hey, wait, you're trying to change something that's private. That's forbidden. But in Python, everything's voluntary. And you just have to hope that the application programmers are not insane. I'm taking the side of the class developer here, you understand, because that's usually my piece of the action. All right. So one thing that we do to try to make it less attractive for application developers to do direct accessing of attributes is to set up a collection of so-called set and get methods that allow you to modify an attribute if you want to, or retrieve the value of an attribute if you want to. And one of the good things about having set methods in particular is that you can have logic inside the set method that will check the validity of what it is you're trying to do. So if I have a set name method in my employee class, that encourages the application developer to say something like John.setName and call the setName function instead of accessing the private data directly. And the setName function can have logic in it that evaluates the string and says, wait a minute, that's ridiculous. You can't have that as a name, and just reject the attempt to set this name to some bogus string. But then we have people like Prince. I can't draw the symbol, but Prince had his name legally changed to an icon. I guess we're just not going to allow superstars to be hired into our company. Okay, Anyway, we've added set name and set rate to our employee class, and we've also added 3 get functions: get name, get ID, and get rate as well, to try to persuade the application developers to use these named interface functions instead of just going directly in and accessing the private data. We intentionally left out a set ID function here because generally when a company hires an employee and assigns an ID number to that employee, that ID number is going to remain fixed forever. No other employee is ever going to have that same ID number, even after that person leaves the company. Okay, so that the company can have accurate records, of what they paid each employee, and tax records for the employees, and what assignments the employee had. An employee may leave the company for a few years and come back and be given the same ID again, because they're still the same person, and now they're back with the company, so they still have the same ID. And we don't want our application developers to willy-nilly be changing employees' ID numbers. Okay, but we can't prevent it. In Python, we can't prevent it. We can just hope that application developers follow the rules. Okay, so here is some more respectful code using our get functions to obtain John's and Ed's rates, compare them to each other, and then to display John's and Ed's names. All right? These attributes inside of the employee objects are often also called instance variables. This matters in case you are talking to people who care about object-oriented programming and may be familiar with other languages, let's say. So the idea of an instance variable is an attribute variable that is contained within each instance of a class. So John is an instance of an employee. Ed is an instance of an employee. I might have Alice being an instance of an employee. And John has its own instances, its own occurrences of the underscore name, underscore ID, and underscore rate variables. Likewise, Ed has its own occurrences of underscore name, underscore ID, and underscore rate. It's possible to have a variable that belongs to the class as a whole rather than to each instance of a class, and such things are called class variables. So we have this employee class, and we have the ability to create employee objects, and each employee object, each employee instance, is going to have within it these instance variables, these state variables, underscore name, underscore ID, underscore rate. What might we be interested in knowing about the employee class as a whole? Well, one obvious thing that we might want to know about any class is how many objects of that class currently exist. How many employees are there right now? How many employees have ever been fired? Fired. I skipped a step. How many employees have ever been hired? So how many employee objects exist now? How many employee objects have ever been created? These are kinds of information that belong to the class, not to John or Ed or Alice or whoever. And so here is how we could create a class variable that belongs to the class as a whole. You just give an attribute name outside of any method definition and assign some value to that thing. In this case, I'm creating a class variable named numCreated, which is initially 0, because when the program first starts running, I have not hired anybody yet. So the number of employees that have ever been created starts out at 0. Then, let's suppose I create an employee. I hire John. Well, that's going to invoke this init method, and for John's self, the John object is going to have the underscore name, underscore ID, and underscore rate instance variables created, but also the class as a whole, the employee class as a whole, is going to have the number of employee objects created incremented by 1. Later on, when I hire Ed, the init function will be called for Ed, and we'll have the Ed objects, name instance, an ID instance, and rate instance. And the employee class's number created is going to be incremented again. And so when I hire, Alice and Julie and Bob and whoever else, each time I hire somebody, the employee class's num created class variable is increased by 1. Seem reasonable? Okay. Now, I can access a class variable either by specifying it as an attribute of the class itself. So employee.numCreated will tell me the value of the numCreated class variable. I can also use an individual employee object .numCreated, and that will also work. But those are the only two ways that I can access how many employees have been created. There is, for example, no global variable named numCreated that accesses the number of employees that have been currently created. All right, so that's a sketch of how to define a class and some of the important issues involved. Yeah?
If you want to define a method that works on class variables, do you still need to include itself as an argument?
Actually, you can't, because the whole thing about a class variable is that it's outside of the individual. So I'm glad you asked that, because I wasn't clear. When the init function here is invoked, when the init method is called, these 4 statements are executed. The first 3 of those statements do modify an attribute within the self, but the final statement modifies an attribute of the class as a whole. So this init function is modifying a class variable. If I accidentally said, and this is very common, by the way, if I said self.numCreated, that would only count how many times John was created, and it would always be 1. Okay? Good. Any other questions? Okay. All right. So now we're going to take a look at another important feature of object-oriented programming, which is the whole idea of inheritance. Inheritance allows you to specify that one class is a kind of some other class. And it's this is a kind of relationship between different types that essentially is the key part of object-oriented programming. The ability to create classes independently of each other, historically that was called creating abstract data types. So you can create trees, you can create lists, you can create employees, you can create cubes, you can create line charts, and these are all sort of independent of each other. The addition of the inheritance and the is a kind of relationship is what sort of pushed abstract data type programming forward into object-oriented, what was called object-oriented programming. So in our case, we have a bunch of employees. Some of these employees have more responsibilities, a broader range of behaviors, what have you. A manager in a company is a kind of employee, but a manager also has things like a budget and things like a set of employees that report to the manager, and various projects that the manager is responsible, and so on. So there's more state and more responsibilities for the manager, in addition to all of the state and responsibilities that already exist for the employee class. All right, so if we define a manager class using inheritance, which we should, the manager data type is going to inherit everything that we've already defined about the employee class, but then there will also be some additional things that are special to managers that other employees don't have. All right, so in order to create our manager class imported from employee, we're going to have to import the employee module that we had previously created so that we know what an employee consists of. And then the notation for doing inheritance is like so. We say class manager, and in parentheses we indicate that manager is derived from the employee, well, base class would be the C++ term for that, or superclass in Python lingo. Now, okay, so a manager is a kind of employee, and technically, if you're thinking about this in terms of sets, that means that the employee is the superclass of the manager, because managers are like a subset within the whole class of employees. A lot of people are kind of confused about that, though, because it sounds like, well, if an employee is a superclass of manager, boy, if employee is super, shouldn't an employee be able to do more stuff than a manager? And exactly the opposite is true. The manager can do more stuff than the employee. The manager can do everything that the employees can do, and more stuff. So, anyway. Now, we're always going to need a dunder init function and a dunder stir function for any new class that we define. So we need these for manager as well as for employee. Notice that our manager is going to be initialized with a name, an ID number, a rate, and a budget. Okay, so the manager is going to be initialized with more stuff than the employee is. The name, the ID number, and the rate actually need to be sent down to the superclass. Sent to the superclass, and we indicate that by saying super and invoke the superclass's init function, which in this case would be the employee class's init function, which saves the name, ID, and rate into instance variables at the employee level. All right, so now that we've saved the name, ID, and rate into employee level instances, we need to create a manager level instance, underscore budget, to keep track of the manager's budget. Now, we were a little bit careful when we defined the dunder stir method for employees to make that stir method extensible in a convenient way. So, in order to display, or in order to convert a manager object into a string, we're just going to get the employee string part first, all right? So we invoke the superclass's dunder stir method, and then we're going to append information about the manager's budget. And because we have this budget attribute, we also are going to create setBudget and getBudget methods. And so now here we have our testing code for the manager class. We're going to create an ordinary employee John, as before, an ordinary employee Ed, as before, and we'll give Ed a raise. Here we have a manager named Ann, whose name, employee div 3, and rate of 88.75 those are all in the employee part of Ann. But Ann, as a manager, also has a budget that we're going to keep track of. And when I print Ann, that will invoke the manager class's Dunder-Stir method rather than the employee class's Dunder-Stir method. So the output that I get has the same information about John that I had, the same information about Ed that I had, but we have additional information about Ann, because in addition to ID number, name, and salary, or rate, I wasn't very consistent here. I should have called these rate rather than salary. I would not want an annual salary of $88.75, I don't think. And then here we also have Ann's budget displayed after the employee stuff. Okay, so that was a fairly hasty sketch of what's going on with defining classes and making use of inheritance with classes. Any questions? Yes?
Is there a way you can implicitly call the superclass string function with any other format like this?
We need to use from within the manager class. We need to use super to get at the superclass's Dunder-Stir function. And at a user level, I don't. I don't know of a direct syntactic mechanism for doing that. Very likely there is one that I just don't know about.
So even if we just call super and then parentheses, would that work?
Let us try. I have all these code files open, so let me pull one up. Here is my manager code. This is the same manager code that's in the notes. And let me run it and first show that it does what I claim. Okay, so I get John, Ed, Ann, and if I ask to see John, I'm going to get told that John is an object, which is not very helpful. Ed, Ann, whoops, it's lowercase Ann. All right, so I get told these things are object, which is not very helpful. But if I say Ann dot, now I do get a list. This is a feature of idle, not of Python. This is a feature of idle, that I get told all of the methods that exist for Ann. Although I don't get told about the Dunder methods by default in idle. All right, so I can say underscore underscore str underscore underscore parentheses to directly invoke the Dunder-Stir method. And now I'm curious if I say Ann dot super dot stir. Oh, I did that wrong. Ann dot super, I put the parentheses in the wrong place. Dot str and parentheses. Okay. Manager object has no attribute super. So, I mean, that's the way that would have occurred to me to try, and it's not behaving. Now, I can blow past the well, I can be legitimate about this. I can say print my hands are just a little bit too far to the left. Okay. I can say print and get name and get ID and get rate to get that information. So I do have a legitimate way of getting at each one of those pieces of information.
I was actually asking whether inside the manager class in the STR method, whether you could call like super and then it would implicitly call the STR distribution. Inside the manager class, where you define this.
Isn't that what we did? I mean, that's what we did here.
Using super dot STR.
Yeah.
Would this be the same as super and then plus comma budget or would it then implicitly call the STR function of the super?
Sorry, I think I'm missing some key element of your question here.
Yeah, so this is one statement that you want.
Yeah.
I want to write return super and then open parentheses, close parentheses, plus comma budget, colon, whatever.
Oh, well that definitely won't work because if I just say super like that, that's what you mean?
Yeah.
Super is not a string. Super is an employee class.
Then would that not call STR implicitly?
No, it's like if I do this, if I say hello if I were to say something like hello plus 5, stir doesn't get implicitly called on 5, I just get an error. I have to explicitly call stir. And inside of the class code, I have to explicitly call stir by using its method name. Okay, I think I finally understood. Sorry about that. Other question, yeah. Inherit from multiple classes? Yes, and don't. Most object-oriented languages, and I believe that I have seen this in Python as well, do allow you to do what's called multiple inheritance, where a class can have multiple base classes. But the minute you do that, you run into all kinds of collision problems with methods that have the same names between two different base classes, two different parent classes, two different superclasses. And resolving those kinds of conflicts is not worth the pain. I am informed, but I don't have proof, that Google forbids, Google uses a lot of C++ code for algorithms, but multiple inheritance is something that they just strictly forbid. It's just too prone to bugs. I agree with that opinion. A lot of people think that's idiocy and you should have multiple inheritance all you like. Other questions? See, at various times, I've been not in Python, but this was longer ago in C++. I was an expert. I was a deeply expert person at all of this multiple inheritance stuff and all of this overloading stuff, and would teach it to people. And at a certain point, I realized, you know what? I spend hours and hours and hours and hours teaching people these really hyper complicated rules, and I bet they never use it in their life. And I realized, I've been writing code for years and years and years and years, and I've never used this in my life. So, I don't know. Anyway, I'm probably just stupid. Other questions? Okay. All right, well, so let us get ourselves ready for the quiz. The quiz is going to be happening in, half an hour. Would everyone like to get this quiz going sooner than half an hour? Okay, so let me, let's take a shorter break, and I will use that time to edit the time on the quiz so that we can start sooner. Let's take a